Hello, everybody. Designing APIs is not an easy thing, but it requires a lot of technique and also languages. And we had a series already published that is called The Language of API Design. And today we're going to a third part. But first, let's welcome our guest who has written these pieces that we're referring to, David Biesack, who is the Chief API Officer at Aperture. Hey, David, thanks for joining. How are you doing?
I'm doing great, Eric. Thank you. Thanks for having me.
Yeah, and thanks again for doing this long series with us, so to speak. Let's very briefly look back at the two pieces that we had already. So the first one that we had was called Creating Your Domain Model. What did we cover, or what did you cover in the pieces that we discussed in that first episode?
So the first episode, we really talked about going back to why you're creating an API to begin with. So you have to know about what's the business problem you're trying to solve, who are the stakeholders for that API, understanding how they're going to use the API, and then creating a domain model using domain-driven design or other techniques that capture the intent of the API and make sure that you're sharing and understanding and have a common understanding with your stakeholders about what the API is going to do. And that's going to set you up to success so that then when you actually create the API, it's solving a business problem. It's doing what the consumers are going to really need.
Yeah, and I think it's really great that you have this first phase, right, where you say, let's not jump into the technical things. Let's first discuss what we are actually doing here in terms of solving a business problem. And once you've done that, once you have a domain model and you have a clearly defined business model behind it, so to speak, then the next video, the second episode that we did, that covers a little bit more technical aspects, and maybe you can briefly describe what we covered in that second episode.
Right. So the next phase is really this translation where you take this domain model, this understanding of what information is available from an API and what operations does a user need to use the API for? What are the behaviors that they need from the API? And then how do you translate that abstraction into a very specific representation of an API, which is the OpenAPI specification? So it's this literal translation process and understanding how you express various API needs operations, both requests and responses and interaction patterns, et cetera. How do you express the behavior and intent of an API in OpenAPI as a language?
Mm-hmm. And I think it's great to clearly separate those pieces, because I think in theory, not that we talk about it, right, but you could take the domain model and if the API lends itself to that, you could also maybe express that in gRPC or in GraphQL or in some other technology. But for this, we look at OpenAPI. And in that second episode, we discuss a lot of the OpenAPI fundamentals, I would say. And you also jump a little bit into the description of the actual payloads, which is JSON Schema language. And that is a rather complex language itself, which is why it warrants a whole additional episode. And you have written 4 articles on JSON Schema. Can you give us a very brief rundown, just like what do these 4 things cover before we jump into each one of them for a little bit longer?
Yeah, it's 4 articles, but there'll probably be more. But the first article is just titled Learning the Language of API Data. And that's really your introduction into JSON Schema, understanding that JSON Schema, what it really was intended for, and it's an existing standard, and then how is it interpreted or used within OpenAPI, and understanding that really there's a dual purpose between JSON or with JSON Schema, one of which is doing JSON validation, and then the other is modeling data. And we explain how to use JSON Schema to model both your request data, your request bodies, and the response bodies that come out of your API.
Mm-hmm. And then we have more on the model aspect, where it's about composing models. I think that's also really good, because that like dives deeper into the idea that you're probably not just designing one API. You probably, at least in many organizations, you have more than one, right? And then it makes sense to look at it with a little bit of modularization in mind. And then the last 2 ones, I think, we'll jump into those when we actually discuss the details. I think these really then become these kind of really advanced topics that a lot of people maybe haven't heard about, or haven't heard enough about. But let's first briefly talk about what you're covering in that learning the language of API data, because I think that really is that point where people realize that, oh, it's not just open API, there's something else in there. And then that other thing is JSON schema. And the question then is like, how do you handle the fact that you have these two specifications, and how do you manage that also as a practitioner who needs to kind of do both, design the API and design the payloads?
Right. So really trying to understand the structure of JSON schema is one of the important parts to start off with. So you can use JSON schema to describe all sorts of data, simple text strings, but then also objects. So JSON can be arrays or objects or primitive data, and JSON schema can be used to describe all of those, and you can have properties, etc. And what's key that I introduce is this notion of the recursive nature of JSON schema and how schemas are composed of other schemas. So when you're defining an object, for example, and you have a bunch of properties, A, B, C, and D, the description of each of those properties is defined with yet another JSON schema or a nested schema. So I talk about that and make sure people understand how everything is composed to create schemas built upon other schemas, and understanding that recursive nature of JSON schema. And it's really a very elegant way and very expressive way of describing your data. So we kind of cover that as the primary topic, but also making sure people are aware that JSON schema was originally designed as a validation language to validate a JSON payload. So its first intent is not really is modeling. So there's this, again, it's this translation or interpretation of, here are the validation aspects of JSON schema, keywords like properties and minimum and maximum values, et cetera, and then how and type, et cetera. And then how are those interpreted to actually implement your data? And that might involve generating SDKs from your JSON schema to create data models, types and classes and interfaces in a programming language to work with that data and work with it with more stricter typing and things like that. So there's that interpretation of the validation aspect of JSON schema that's used for the modeling aspect, and understanding that dichotomy of JSON schema is really important.
Yeah, I think that's a very good point. I think it helps a lot when you understand the origins, how something was created initially, because then sometimes I think it also helps you to better accept, maybe also understand and use like some of the things that you otherwise might think are a little strange, or you're wondering what was going on. So those are the things. Is that just all the stuff that you're handling in that first article, or is that already like going into the second article where you talk about the composability more?
It's kind of split a little bit. So the second article is where we talk about how to use JSON schema to compose data. And it's not so much this nested structure of JSON schema to describe the data, but rather when you are defining your schemas for your API, how you use JSON schema effectively for reuse. So if you've got two different data models, for example, that share a common set of properties, you can compose your two schemas from a primordial schema. So you might define one schema that defines what all those fields are, and then define your two other schemas that reuse those fields. So you don't have to copy and paste. You can be effective with your design of APIs and API data with JSON schemas. So that's where I talk about how to compose your own schemas by reusing other schema elements and doing that effectively. And then some of the constraints and behaviors of JSON schema that you need to be aware of to do that correctly, and where you might run into some problems and how to avoid those problems.
Mm-hmm. And you are mentioning this dry principle there, the don't repeat yourself principle. And you were also mentioning right now, so that you can avoid copy and pasting things. And I think that's such a great golden rule, right? Whenever I think anywhere in computer things, when you start copy pasting things, think twice. Right? It may
Right.
not be the best thing to do, and I think in that part, definitely, it's something where that's a very good indication that maybe I should actually reuse that properly.
Right.
Okay, so now we have a better idea of how JSON schema works. We also have a little bit of an idea of how we manage our models in a better way so that we don't do this copy pasting thing. And now I think you're diving a little bit deeper into some of the really meaty parts of the specification. So what's the third article about, where you say you're covering a little bit of the subtleties of JSON
Right.
schema, and
Right.
it is a non-trivial language, right?
Yeah, it is. It is. And so there's actually, I split it up into two parts because it was really just a lot of stuff and I couldn't get it all into one post. People wouldn't read that much
I
information.
also, I like the titles where it says like subtleties and then more subtleties.
Yes, that's basically what it is.
Yeah, so let's cover those two together. I think that's maybe the best way, or
Right.
if there is not a logical split, so to speak.
Yeah. So what I'm trying to do is really kind of explain things where people who are casual observers of JSON schema might make assumptions about what they're reading, and really kind of clarifying why those assumptions don't necessarily pay out. So for example, when you define a schema and then you define a set of properties for that schema, that doesn't imply that the type of that schema is an object. If you leave off the type keyword, then the JSON schema will basically validate whatever you have. So some people might interpret this incorrectly by saying if you're defining properties, then you must be defining an object, but you have to be explicit about those types of things. So I explain those types of rules. There's another keyword in JSON schema called additional properties, and that's a way to say, what I've defined for you are a set of these properties, but no more. I don't allow any additional properties. But there's some subtleties around the use of that additional properties that work in some cases, but it doesn't do what you really expect it to do in other cases. And so I kind of go into the very fine details of how to use that correctly, and how you might want to think about using a different keyword, which was introduced in a later version of the JSON schema specification from 2012 or 2020, which is called unevaluated properties. So really, these two articles kind of talk about some of these more subtle aspects of JSON schema and some of the traps you might fall into if you don't understand what these keywords mean and how they're used, and then provide some better guidance on how to use them correctly to get what you want, and avoid the things that you don't want.
Mm-hmm. I'm wondering, I had a little while ago, I had a video with Henry Andrews, who's one of the editors of JSON Schema,
Yeah.
and his big thing, so to speak, was, and I like that a lot, where he said, the problem that a lot of people have is that they don't understand that JSON schema is a constraint system. It's all about, constraining things. It's not additional, so to speak. It subtracts things, right? You define constraints, and that kind
Exactly.
of constrains what is allowed. And I think that thinking sometimes takes a little bit of getting used to. Is that an experience that you had yourself?
Oh yeah, definitely. I think that's the first thing that people fall into that trap is when you're using this composition model in JSON schema, there's an all of keyword that says this schema consists of all of these other schemas, and you have an array of other schemas, either references or inline schemas, and say this schema is all of schemas A, B, C, and D. And initially, people often misinterpret that and think of it as an inheritance model. But it's not. It's a composition model, and as you said, it's additive. You can't take away something. So if you say it's all of schemas A, B, C, and D, all of those validations for each of those schemas will apply for the composed schema. You can't remove a validation. So if one of those schemas says the type is object, you can't in another schema say the type is null, because now you'll have a conflict. You'll have two different schemas that together they won't validate. If something is a type, it will validate against one schema, but it won't match the type null of the other schema. And so nothing will actually match. And that you have to be aware of is that this is not inheritance. You can't override things that you pick up via these other schemas. You can only add. So you have to be very careful about how you compose things. And I have some examples of doing that, where sometimes you want to declare the type of something as an object, but maybe you want to defer that until later where it's actually used because you may decide the type is not just an object, but it might be an object or it might be null. For example, you might want to allow someone to pass in a null to remove a value in a put operation, for example, or a JSON patch operation. And so you need to be able to specify something as a nullable value. And it's a different interpretation with JSON schema from the 2020 spec versus what was in the older version of OpenAPI, where they had a nullable keyword. So that's no longer in effect. And so you have to understand how these types are composed. It's very complex, but it's all explained in the article.
Yes, and you're also hinting, and let's not dive into this. You're also hinting at the fun history of JSON schema, where it was created initially, then OpenAPI adopted it, but then OpenAPI kind of forked it and kept its own version, and now things are being brought together again, which is good, but it's just
yes,
it's not trivial, so to speak, to understand the history of the languages of API design.
No, definitely
so I
not.
think your articles, yeah, but I think your articles do a really good job of explaining, what you end up with, and what to do and also what not to do. I think that also is oftentimes a very good advice. David, thank you so much for all the work that you put into these articles. I think these are a great resource for anybody who wants to learn more about API design and the languages of API design. Do you have any closing words for us, or any plans you would like to share, how maybe we continue? So you said, okay, these 3 ones that we have now for now will be enough, but you'll keep on writing. So
oh yeah, I'm definitely writing. So like right now I'm in the middle of writing an article about kind of the language of API security. So how do you express different aspects of API security in an open API? And JSON schema plays a part of that. As I mentioned, the things like those additional properties or unevaluated properties are a way of avoiding certain API security vulnerabilities. And I'm going to talk about API security and scopes and security constraints or security requirements and security schemes, et cetera. So there's lots of other aspects of APIs and the language aspect and understanding and interpreting and expressing API ideas. And I'm going to just continue writing about that.
Yeah, I'm sure we will see many more things popping up. Very brief question. Will you write anything about linting? Is that something that's on your radar? You could say that's kind of a language also where you encode certain guidelines, certain constraints, so to speak,
Yes.
that you have for designs. Is that something that you're looking into?
Oh yeah, definitely, and that's part of this security aspect of API design. So there's lots of good tools. A widely used tool is Spectral. We use that at our company at Aperture, and we have our own custom Spectral rule sets, and using that to look at your API and make sure that you've not done something wrong. So there's actually a OWASP API security top 10 rule set that works within Spectral to look at your API design and make sure you're not doing things that could potentially open you up to vulnerabilities. So linting is certainly a very important aspect of API design. And I'll talk about other things too, of creating mocks from your open API, and doing other types of testing, automatic test case generation. There's lots of things you can do because OpenAPI is expressed as a JSON document that you can analyze and process with all sorts of other tools. And that's a really important aspect of OpenAPI and API design.
Okay, great. I'll definitely keep following your Substack channel, and I would like to encourage everybody to do the same. We'll, of course, link to all the articles from the description of this video. Also, if you like this, check out the previous ones that we talked about in the beginning. And with that, we're done for today. Thanks again, David, for joining.
Thanks so much for having me. Appreciate it.
Thanks, everybody, for watching. If you liked it, please give it a thumbs up, consider subscribing, and keep getting APIs to work. Bye-bye.
Bye.